So let's look at an example then of how this is combined. If we can work out how it works, then we can use that method to calculate the values of R and alpha. So let's look at this, particularly this bit of it, sine omega t plus phi. Well, that's like sine A plus B, that combined angle formula that we've looked at already. And we know that sine A plus B is sine A cos B plus cos A sine B, that combined angle formula. And we've used that before. And so if we let A be omega t and B be phi, then we can sort of rewrite this r sine omega t plus alpha using the compound angle formula. So r, because r is in front of it, and then brackets, this is how the combined angle formula looks like. A is omega t, so sine omega t cos phi plus cos omega t sine phi. You can see how that works. If we think for a minute about this omega t here, the sine omega t, that's the wave function. If we look back at this, that omega t is what's allowing the wave to do this. The phi is just a phase angle, one number that just shifts the wave this way. If we add phi, it shifts the waves that way. So that's a constant. The changing thing is the omega t, because t is the variable, the thing that's changing. So that's the changing part about it. So if we think about that in here, the cos phi and the sine phi are fixed. They're constants. For a given value of phi, they don't change. Cos omega t is a cosine wave, continually changing. It depends on time. But sine phi is just a number, and so is cos phi. So if we expand out this bracket, we get r cos phi sine omega t and r sine phi cos omega t. All I've done is put the bits that are constant together, and then the cosine function, the thing that's changing at the end. The bit that's constant together and the bit that's changing at the end. Now if we look at this, and we look back at our original formula, r sine omega t plus phi, the phase angle, equals a sine omega t plus b cos omega t. Our original expression, if we look back, we'll see it. Look, it's all about changing something that looks like a sine omega t plus b cos omega t into this. Well, we've effectively done that if we look at this. A is the r cos phi bit, and if we call A the r cos phi bit and B the r sine phi bit, then we've got our values for A and B. So we know what the relationship is between A and r cos phi and B and r sine phi. So we can say that A equals r cos phi and B equals r sine phi. And if we relate these to a right-angled triangle, we can see how they fit. If we think of this angle phi here, this angle phi, then the sine of phi from that right-angled triangle is opposite over hypotenuse, b over r. And rearranging that, b equals r sine phi, which is what we've got. And similarly, the cosine of phi equals a over r.